In this video, we'll discuss kinetic energy, which is a part of our discussion on work energy and power. So, kinetic energy is one of the forms of energy which is defined as the energy possessed by the body by virtue of its motion. That is, it is an energy related to a motion of a body. Energy related to the motion of the body. As you are following me with the note with you, students, so body moving with a great velocity, then it will possess what? A great kinetic energy. Okay, it will possess a great kinetic energy in comparison of the body moving with a slower velocity. So the higher the velocity, the higher will be the kinetic energy possessed by that body. So consider a body of mass m moving under the influence of a constant force F. You know that forces are constant or there are variable forces. Okay, we can have constant force and we can have a variable force. That means a force varying through time and maybe through position. From Newton's second law of motion, you know that force is equal to mass times acceleration. Force is equal to mass times acceleration, which is the force is, you know, that the resultant force or the net force here. The force is always the resultant or the net force. The acceleration is the rate of change of velocity. You know that acceleration is the rate of change of velocity. So if this acceleration is due to a force application by the body, and this is from velocity 1 to velocity 2 during the displacement d, then from the equation of constant motion, you know that acceleration can be calculated from this known formula. You know that there are 5 formulas we have discussed in. We have discussed 5 formulas. Among the 5 formulas, we know that this v2 square, the final velocity square, minus initial velocity square is equal to 2 times the acceleration and the displacement, which is d in our case, in work energy relationship. So the acceleration can be, arranging this formula, we can calculate the acceleration, which is equal to v2 square v minus v1 square over 2s. So now come back to the Newton's second law, which is force is equal to mass times acceleration. You know this is the mass, so this part is acceleration. This all part is what? The acceleration of the motion. This all part is what? The acceleration of the motion. This all part is acceleration of the motion. You know that this is acceleration of the motion. So now work done by the body due to this force is, you know that force work is equal to force times distance, or the magnitude of the force times the magnitude of the distance. Assume that this is in the same direction, so the cosine value here is 1. That is why we said force times distance. Now rearrange the formula, substitute s here. You know that f is from the above formula, this one, mass times v2 square minus v1 square over 2s. Now the work becomes half mv square minus half mv square. That is the final velocity and the initial velocity. Now we can conclude that work done is the change in kinetic energy, simply the change in kinetic energy, because this is kinetic energy and this is kinetic energy. We have 2 kinetic energies, kinetic energy before and kinetic energy after. What does it mean? We applied a force to accelerate the body, so we changed the kinetic energy of the body. If the first case, the first instant, if the body was in, that means at rest, so the kinetic energy will be simply the kinetic energy after the motion starts. If it was moving with some velocity, but we increased the velocity due to some application of force, the work done will be the change in kinetic energy. The change in kinetic energy. That means work done, you know that it is a transfer of energy from one body to the other body. That means the increase in energy of that body, a moving body already, due to the application of some force, is the change in kinetic energy, which is kinetic energy of the body. Now look, Finally, we can define kinetic energy of a body as 1/2 of the product of mass of the body and the square of its speed. Look, here this speed is magnitude of velocity. Okay, the speed is magnitude of velocity. That means if you have given velocity in, for example, vector form, a component form, to apply the kinetic energy equation, you have to use the magnitude of that velocity. Keep this in mind. The magnitude of that velocity. We'll see an example. So kinetic energy 2 is equal to mass times velocity 2 square over 2. It is final kinetic energy of the body. Kinetic energy 1 is initial kinetic energy of the body. Okay? So the equation becomes work is equal to kinetic energy 2 minus kinetic energy 1, which is change in kinetic energy. So the kinetic energy of the change in kinetic energy of a body is the work done on that body due to the force applied. Due to the force applied. Okay, keep that our definition for a work done was the change in energy or the energy transfer from one body to the other. So we can do simple example. Okay, simple example on this concept. The kinetic energy is scalar quantity and its SI unit is joule, just like of work. So calculate kinetic energy of an object of mass 10 kg and velocity 5 meters per second. This is enough. So kinetic energy of that body with this velocity is simply kinetic energy is equal to half mv square. Kinetic energy is equal to half times mass times velocity square, which is 125 joule. What does it mean? The force applied on the body to increase or to move the body, okay, gives the body 125 joule of energy. The body gets or gains 125 joule of energy due to the force applied to move that body. Any force, okay? The force may come from any source. The other is calculate the kinetic energy of the object of mass 10 kg and velocity. Look, the velocity is given 2I plus 3J meter per second at any instant. So the velocity here is given in a component form or the vector form. Keep in mind that the velocity should be in magnitude. So here we can calculate the kinetic energy as follows. Kinetic energy is equal to half mv square. The same formula. Half mass is 10, the same, but the velocity is given in the component form or the vector form. So we have said that the magnitude of the velocity, which is the speed, is simply x square y square. That one, x square y square is the magnitude under the radical. So 2 square 4, 3 square 9. So 4 plus 9 is 13. Okay, times 13 under the radical 30. Okay, square root of 13 here. Square root of 13 should be square root of 13. Magnitude is square root of 13. Square root of 13. That is the magnitude of the velocity. The magnitude of the velocity is square root of 13. Okay, so kinetic energy is equal to half times 10 times square root of this value, which comes 65 joule of energy. So there is important note here. When a net force does work on an object, then there is always a change in what? Kinetic energy of the object. This is because the object experiences acceleration and therefore change in velocity. That is the concept of kinetic energy in work, okay, definition. You know that the work definition is a change in energy or form of energy from one form to the other, from one body to the other. So based on this, okay, based on this concept and your understanding, I will give you a question later on from the entrance exam, and as of the first what we have. So please try this question also. Okay, I'll give you the question and I will see your answer. Thank you very much.